So today's agenda, the troublemaking panel. We have a great group here today, and I'm excited here to present them or to introduce them here shortly. Then we're going to get into the troublemaking data. So we went through a lot of warnings data and came to some really interesting conclusions in that data. I'm going to present that. Then we get into the most common troublemakers. So these are the ones that we saw the most of across the data set that we examined. Then we get into the biggest troublemakers. So these are the warnings that have the biggest impact to your projects. And then we're going to give it a little bit of guidance on how to resolve warnings and follow it up with the Q&A. Now, you may be asking, what's the deal with all this troublemaking and troublemakers and whatnot? I think this is quite fitting to use troublemakers and using warnings and people and projects as troublemakers, because when you look at this data, you can see that there's a few outliers along the way, and to label them troublemakers, I think it's apt. All right, getting into the panel today. So we've got a great panel that spans across many different disciplines, many different regions, and even the globe. So we've got John Weimer from Garver. He's a BIM manager there. We've got Jess. Oh man, Jess, I was like, man, I'm gonna mispronounce your name. Jess Hallersis. He's a senior associate at Integrated Architecture Solutions in the Philippines. So Jess is all the way on the other side of the world, and he's calling in. I think it's 4 a.m. for him. So thank you, Jess, for attending at such an early hour. Then Kenny Hunter, who's the Director of Design Technology at PAE Engineers. Mike Ramos, who is the Model Manager at WD Manor. And Rowan Isaku, who's Associate Principal and Practice Technology Leader at HDR. So I want to welcome all of you to this webinar and thank you for your participation over these months leading up to today. So with that, let's go ahead and get into it. So when we at Guardian released 3.3, we introduced not just warning tracking, but we added a layer to that, adding the ability to provide that monitor, guide, and prevent to all of the warnings. As part of that presentation, that release presentation, I had included this slide. This is something that I worked on years ago, and a team of us anecdotally kind of put together this simple chart here that shows the impact warnings has on model performance. And so when I start to look at that again after so many years, I thought, oh, we have a good opportunity to kind of go through a lot of data and see if we can empirically prove that this is actually true, if this amount of warnings causes that level of performance impact. So this is how this whole idea got started. And then we sort of got into the flow of really looking at the data. So talking about the data, troublemaking data, we went through an anonymized set of 10 firms' data and looking at each of their warnings. And when I say each of their warnings, we went through so many of these warnings, and we started to look at try to make heads or tails of what this data means. When we first set out, we thought we would see that there is a correlation between the number of warnings and the model size, sync times, open times, and unfortunately, we didn't find that. But through the conversations and kind of continuing to looking through the data, what we did find and what we realized is while warnings may not have that impact on the model size and sync times and open times, but it does have impact on the everyday performance. This is something anecdotally we've all seen. And we've also, through the data, and kind of highlighting here is warnings just don't grow with projects, they kind of compound. And so the bigger that project is, the more warnings you have. And thus, you have more people who are generating more warnings, and thus, as these projects grow, they don't scale well when it comes to warnings. And so this is where you start seeing those performance impacts on your project. More people equals more warnings. And so you may be asking, well, what is that performance impact? So we did a little study here in which we just showed a model, just simply modeling a wall. And here on the right, you can see that we have Event Monitor live. And as you're just placing that wall, you can see that in these transactions, there is something called the failures processing. This is Revit processing the warnings as you're modeling. And so while this was a small project, we speculated on a very big project with lots of warnings, you would see your everyday picks and clicks within that Revit kind of slowing down. And out of curiosity, and just for the people who are listening in here, what are those type of experiences you've seen with warnings? Have you seen models slow down with the picks and clicks? So transitioning here, we started to look at really in depth of all this warning data. So we first looked at the number of warnings by model. And a couple of things that we've really noticed kind of across the board when we looked at all the various data sets. One is there was always that troublemaking layer. So here we looked at the top 10% of warnings by model, and 69% of all models, or excuse me, 10% of all models contain 69% of all the warnings. So you can quickly see that there's this outlier. And now we shifted gears and we looked at the warnings by users. So the top 10% of users generated 78% of the warnings. And so when you look at that number, right, the total number of warnings, 62, almost 63 million warnings that had been generated in this data set by users. Now, we always like to talk about the 80-20 rule. And so we thought, well, when we throw this in a little graph here. So here, 80% of the 80% of the warnings were generated by only 11% of the warnings. Excuse me, I had that backwards. 11% of the users. So really, warnings aren't just a Revit problem. They're kind of a behavioral / scale problem. And Jess actually, he went through his own data a little bit in more depth, and he found a key insight. He noticed that his power users are actually the biggest generator of warnings, which was kind of surprising, as I think most of us would assume that our less experienced users would have been that. Jess, do you have anything to add to that finding of yours?
So the probable reason that I can think why our power users are the most generators of Revit warnings is because they work faster, they push the model harder, and they operate in the most complex area. So simply put it, the more you edit, the more you disrupt constraints, overlaps, joins, room families, and whatnot. So in practice, the people doing the most work often generate the most warnings.
Thanks for that context, Jess. As you were saying that, I was thinking within architecture, we sort of have this perception, you work harder, not smarter. And I think what we're going to demonstrate here is working harder actually, and if you're not paying attention to warnings, is actually slowing you down, right? It's not helping you, it's hindering you. So more to come on that front. So let's go back to those 80%, or excuse me, those users, the warnings by user. We were kind of like, well, you can see that there was a clear outlier. That top 10% just contributed so many of the warnings. But then, so we were like, well, let's just lop off the top 10% and the bottom 10%, look at that middle 80% of users. Even at that rate, the top 12% 25% of the users still contribute to 54% of the warnings. So you can see this is very much a top-end problem because sort of however you slice it. All right, with that being said, is I just want to open up to the panel here. Was there anything else about this data that surprised you as we went through this exercise in preparation for today? And John, I'm going to put you on the spot there.
Just the sheer number of warnings that people can create just unintentionally. You know, like Jess said, you got your power users that are just working, chugging along. Well, most people aren't aware of how many warnings they kind of leave in their wake as they're just working along.
I think it's a really interesting way of putting it, right? You kind of generate a wake that causes disruption that you yourself is not subject to at that moment. So with that being said, why don't we shift gears here a little bit and let's get into the most common troublemakers. So to set the stage a little bit, we generated this chart, and at the end of the day, we looked at, once you really consolidated the data down, there are about 460 unique warnings across the entire data set. As you can see, there is one significant outlier here. And when I was saying earlier, and I think there were some reactions in the chat here, is we're talking millions. You can see here that one warning was generated significantly, I would say millions times more than all the others. It's not very often you can say a million times more than all the others and you actually be correct there and not exaggerating. So that came down to coordination monitor. So as you can see, out of the entire data set that we looked at, almost 74 million of the warnings were dedicated to coordination monitor alert. And then when you really slice it down on the individual types of coordination monitor alerts, the very top one there, a hosting element, no longer exists in the link, takes the cake of almost all of it. So out of curiosity, and I'm going to look to you, Mike, and Kenny, is when you go down this list, especially the ones highlighted in red, what does this tell you about what is coordination alert and why this is being generated in your models?
So I'll go for, yeah, thanks, Mike. Coordination monitor alerts for us in the MEP space. And first of all, I want to apologize if a lot of these are generated by MEP, simply because we use the tool in Revit called Copy Monitor, and we rely heavily on keeping our levels and our grids coordinated, which is tremendously valuable in making sure we're aligned with the architecture and structure. Copy Monitor also has the ability to link and monitor other elements. So if you copy monitor light fixtures as an example, or plumbing fixtures would be another example there, then you will find yourself getting more of these alerts than not, simply for the fact that architects change things. Plumbing fixtures come and go, and they move, and they get deleted. The same could be said for anything you might be hosting in the link. So if you have face-based elements that are hosted to a wall, that wall gets deleted and redrawn, or you have ceiling-based elements, ceiling gets deleted. And for me, hosted elements are kind of the reason why this one exists for the most part. Mike, what do you think? Do you have more to add to that?
It's interesting because the warning is caused by something you're supposed to be doing with right. your other trades, with your other teammates, right? This software is designed to kind of coordinate. Yet here we are looking at warnings because we're coordinating. You know what I mean? So it's kind of an interesting warning because I don't know if I'm supposed to be doing this or am I not supposed to be doing this. But are we using the software correctly or are we not? It's just a side effect of using the tool for its intended purpose, but it's not. The warnings are not intended for sure.
Yeah. Maybe we can ask our architecture friends to not delete and read in Dremel, or just edit instead.
I was going to say, way to slide in the little dig there at the
It's
architects.
okay.
Oh,
I'm
the
an engineer
72
at heart.
million.
I'm sorry.
Yes, 72 million. The
Get it,
architect
guys.
moved something last minute. I'm going to say
I'm
that is
kidding.
architecture. That is architecture. Rowan or Jess, anything to add to that?
It's inevitable, change is inevitable. It just happens. But yeah, that is an interesting take on this type of warning, right? So we are using the tool for what it's meant to be using, for what we are meant to be using it for, right? And it is therefore generating the warning. So it could just be that the warnings may be thought of as a good thing, right? We are using the tool for what it's meant to be used. It's just that they shouldn't linger, these particular warnings especially, linger too long, right? Perhaps a couple of days max.
I'm
Yeah, and
curious.
that's a good point, because for us, it is, sorry to interrupt there, Chris, but it's a good indication that those who do pay attention to the warnings, it's a good cue for them to go look at that warning and say, oh, well, something's moved. So it does help with the coordination effort.
Yeah, all of you are exactly right. It is meant to be a good thing, and the question is, and I think if we had more time in preparation, we would want to go back and understand how many of these have been resolved. And I am just curious, when we look at this, especially the top one, such a large number, to me, these are like, I don't know, mass extinction is the word that jumped in my head there. Is this seems like entire models have been linked models have been deleted or removed that had caused thousands, if tens of thousands of families to be to generate this warning. Do you think a lot of this is, and not to try to flip the table here on you, Kenny, do you think this is really a core issue of I don't want to say architects moving things, or people using Revit incorrectly and maybe say deleting a linked model versus just hiding it in or hiding it, or turning it off in a given view?
You're absolutely right. It's not, that certainly does occur from time to time. If a user deletes the model, moves the background, edits it in some fashion in that way, you can generate this many errors. And these warnings in MEP, we have so many fixtures, devices, light fixtures, especially if you just think about ceilings alone, right? There's thousands of light fixtures in projects, thousands of receptacles. So this number climbs really fast, just simply on that alone.
All right, I think we could go all day talking about Coordination Monitor and pointing the fingers between engineers and architects. It's all in good fun. So we took another pass at the top 50 here, and we just eliminated that top Coordination Monitor alert from that. And as you can see, the data starts to normalize relatively quickly. The top 4 are still outliers compared to all the rest. But the top 10, as you can see, now we're getting relatively under 500,000 consistently, 500,000. And those numbers start to drop pretty rapidly from there on out. So this brings up the most common warnings, really kind of drilling into that. Those, when I say common, these are the ones that are common across multiple disciplines. So here, this is really just kind of present, and so everyone can kind of see the numbers. And in some ways, almost to a nod to everyone who spoke on Coordination Monitor, is that this just isn't a engineering problem. It's also an architecture problem. And so you can see, even once you start going down to the next level, like room is not properly enclosed. They're identical places in the same place. You can see, I think everyone here, I assume everyone who's come to this webinar understands these are some of the most common warnings and understand the impact of that. And we're going to get into much more detail as we progress over the next hour. But we're going to shift gears to the most common MEP warnings. So for our engineers here, so why are these warnings generated? I know we talked about coordination monitor, but what causes space is not properly enclosed or elements are disconnected? What happens from a process perspective that generates those warnings?
Well, in a lot of cases with the spaces not properly enclosed region, there's adjustments and changes to the background. The spaces rely on the background's room bounding elements. And if the room bounding elements shift or move, it is that other indication, similar to coordination monitor, right? It's an indication that there's been a change in the space region. You should go investigate, fix it, and sometimes that's just how we go about resolving it, is just fix the boundary or draw room separation lines, because maybe it's a phased project and that part of the building hasn't been modeled yet, and we have to have something there for tagging purposes.
Room separation lines. John, what's your perspective? Or is there any particular one of these that really jumps out of you that you're like, oh man, if I could just get my users to stop doing that?
I'd say the elements are disconnected. Deleting pieces of piping or ductwork system, and it just kind of breaks the whole connection throughout the whole system. That one's one of those warnings that you kind of have to chase it down. They're a little painful to see because it does take a little bit of rework. So that's probably, that one and the space not enclosed are the two most painful ones up there to me.
Yeah.
And Mike, what is yours?
So the relationship between elements deleted. That one for us, we see that when people are constraining some a fixture to a wall for your ADA clearance, so your water closet clearance to the wall 18 inches. A lot of folks will throw a dimension there, a constraint there, and lock it, right? And when that gets deleted or something moves, that dimension or constraint wants to stay there, but something is getting deleted. And we see that more and more as people try to, finalize our designs and everything is locked in place. A lot of constraints come in with them. Those things cause issues, and it starts when things are breaking, and just Revit trying to process through all these constraints. That one stands out to me big time.
It's funny. I wouldn't have picked that one. And when you start going through these lists over and over again, I think we all start to have our favorites, and it's always interesting hearing everyone else speak about their favorites, or maybe their least favorites, and their sort of intimate knowledge of every single one of these. Every single one of these have a story, and we could spend, and we have in preparation to a lot of this, is we have kind of gone through and really got into the weeds of every single one of these. Let's flip this over to architecture. So these are the top architectural warnings. And same question to Rowan and Jess here. Now, why are these warnings, or how are these being generated?
Go ahead, Jess.
Okay, so let me start with the room. So the same with spaces, rooms are governed by the bounding elements. And if the bounding elements are consisted of elements coming from a link, any users can simply unload the link, and the count for the improperly enclosed rooms can easily jump up. So that is one of my favorite, I would say, favorite Revit warnings in relation to architecture. And probably the second one would be the off-axis. So again, on paper, it's pretty easy to commit, and sometimes the user will just simply copy and paste some of the elements from one open Revit model to another without thinking about the origin, the northings of the working models. That's why they can easily generate these kinds of issues, which will haunt them later on the project.
Mark in the chat also highlighted slightly off axis as well. Rowan, what's your favorite troublemakers here?
It would be the ones related to rooms. Those are my favorite troublemakers, or the worst troublemakers, as they not only are annoying, one more thing for you to have to click through, and they cause the performance issues that they cause. But we are also getting into dealing with analytical aspects of these elements, right? These are just not just geometrical, they're analytical. And I plan to say something about that probably at the next slide, or the other slide with the risky business.
Yes, yes. Yeah, when we hold that one until we get to the risky business slide. But that does make a good segue, Rowan, is as we mentioned earlier, we started looking at what we call the biggest troublemakers. So here are what we call the biggest, the most impactful common warnings here. Again, common means the ones that happen across multiple disciplines. A couple things I want to highlight here. All of you can read through this list, but here you can see we started looking at the priority. So this is your high, medium, low that you would find within Guardian or other software, maybe like Model Checker. But we went through the list of warnings and we added another column here. We called this risk, pretty straightforward. And the risk here is the impact of these warnings on the quality or the technical quality of the documentation or the deliverable. And lastly here, and just kind of curiosity, PAW. Curious how many people have heard of this? And these are your performance advisory warnings. These are warnings actually labeled by Autodesk to cause performance issues. Some of them in the warning description, as you can see here in the lower right-hand corner, it's called performance warning. So, and highlighted there, this may hurt performance. So Revit, or I should say Autodesk, is actually highlighting those. So I just want you to pay attention to all of these rankings as we go through the impactful warnings by discipline. So what we're going to do here is we're going to start off with the most impactful MEP warnings. So again, let's open it up to our engineering representatives here. So let's go through the top 5 or 6 of these MEP warnings and discuss how they impact the performance of the model. And what I mean by performance, whether it's the model performance itself, even system performance, or getting into data integrity, coordination, calculations. So John, what is your perspective and on the performance impact of these warnings?
Well, obviously the coordination monitor, pulling in 73 million, that's going to leave Revit thinking the most times over and over again. Every time you draw a duct, a pipe, tag something, in that Revit lookup, when we're able to monitor everything that was going on, those would be the ones that would keep it chugging in circles, thinking through all the warnings that's happening. So those are definitely going to have a high priority to fix, because they're going to slow you down. The raw count of them, plus just they are a pretty risky one. If you're turning off your links, if you're out of line with your levels, that's a high priority to fix for your model integrity and a high risk fix. So that one's definitely there. The elements are disconnected is another model integrity one. That one's always up there in my book of, mentioned it as kind of my least favorite one earlier. So those are the 2 that really jump out the most for me on this.
Mike, how about you?
So not on the top 3, but the elements in the system are not connected. That's kind of a big one that hangs Revit up for us when obviously Revit's trying to calculate flow through any given system, right? Once there's a disconnect, Revit hangs up, and the more systems you have, the longer it hangs Revit up. So much so that we have to shut down our Revit worker.exe. I don't know if people are familiar with that one, that little dandy. In 24, it gets really bad where it's just trying to calculate and calculate and calculate to the point where you can't do your job. So that one's pretty big too.
Thanks for that, Mike. Kenny, I'm curious about yours, but in preparation for today, you have brought up a couple times system performance. So, in addition to talking about your favorite troublemakers here, can you also talk about system performance?
Yeah, sure. So the ones that kind of jump out for me and taking up system performance, items like no loss defined, flow direction mismatch, can't calculate flow. You know, can we trust the system that's in front of us? Can we trust what Revit is telling us about the flow, the pressure drop, right? If our teams want to do color fill legends within their models on their ductwork or on their plumbing work, these are the type of errors that are more barrier warnings to taking advantage of more advanced Revit features, or even features outside of Revit if you wanted to leverage it in some other analytical tools. So those are the ones that deal with your content, your fittings, how they're structured in direction out. Just those are the ones I always kind of gravitate to ensure that if I want to maintain a well-connected system and a trustworthy system, those ones have to be solved.
So the things you kind of hinted on here, you're really getting at sort of digital maturity within a firm. Like how evolved has the firm taken to utilizing Revit to its fullest, really using MEP to not just design, but also do the engineering within Revit. And it sounds like if you want to get to that, you have to have a good understanding of these warnings. So on the flip side of that is what does these warnings say about firms who may not have a good or a more advanced digital maturity?
Well, I would say it certainly has to deal with your content libraries and where that stands and what our philosophy is on that. It's a lot of firms here, and I'll say one right now, at the very bottom warning, calculate flow since all components in the system have a flow configuration to preset or system. Like usually you get stuff like that when you download something from like the internet, Revit City, right? So if your content isn't doing that, that's a great sign. That means you're using good quality content, and whether it's developed in-house or was developed for you. So I would say that's kind of where we've gotten with this, is for that number to be really low, that's good. Lots of people have good content. For as many warnings as we've found, that's telling me, oh, the industry's in a good direction, in a good place. All the data set's solid. So it's showing a trend, and that's something for firms to kind of keep a lookout on with your content is if you see that things like that, no loss defined or K coefficient errors in your templates, those are ones that are kind of, the less those get trending downward over time, you're growing, and you're out now and enabled to take advantage of those advanced features.
And your users are becoming more capable. That means they're learning and so on and so forth. Kind of moving on to the next slide. Here we're focusing on what we call the risky business warnings here. So as you can see, this is sort of the same set of warnings, but filtered by MEP and focused on risk alone. So let's come back to you, John. And if you look at a handful of these, can you describe how these warnings impact that technical quality and then thus induce risk into your projects?
Yeah, the second one, the tap must be attached to duct. I put that one as a high risk because it means that somebody's moved the ductwork, it's broken it, it's no longer going to be computing flow, pressure, velocity, as well as it also just means that there's a modeling practice that happened somewhere along the way that, in Kenny's example, hosting elements to linked ceilings, somebody moved a ceiling raised your diffuser, broke part of your system. You'll have to, move, adjust your system, or maybe someone made changes and didn't say anything. It can be a communication issue, and it can also be a modeling issue from the individuals that are doing the modeling.
And Mike, do you have anything to add? These risky business warnings. Did we lose Mike? All right. Why don't we go ahead and move on to the next slide here? So the next series of slides here, this is some work that Kenny had done, really identifying the top 20 warnings for MEP. And so Kenny, can you explain why these warnings are critical to MEP workflows?
Well, I think it's in continuing the theme that we just talked about. It's system trust and system reliability. Also, that measurement of digital maturity. Some of these items are errors and warnings that people don't really investigate into. They see them pop up here and there, but it doesn't really stop them doing what they're doing, and they just keep going. And some of those could be an example of like K coefficient from number 4 is not supported, and that could simply be because that happens a lot with radius elbows and ductwork, and it simply falls outside the ASHRAE table that Revit uses to verify that this coefficient is valid for this certain size. So if someone makes a custom elbow fitting, a radius elbow, that error will pop up and it'll show quite commonly.
So I think the key takeaway here is if you're utilizing Revit MEP to its fullest, that these warnings themselves really have a true meaning in making sure that those entire systems are working correctly and calculating correctly.
Yep. Revit's telling you what it needs to give you the proper output.
Okay. So it's a helpful warning in some ways, right? And it's not like you're doing something wrong.
Right.
Or potentially not doing something wrong. Depends how you look at it.
Yeah.
All right, let's talk about number 2, electrical and distribution errors.
Yeah, things get left off. When it comes to our deliverables in itself, making sure that our panel schedules convey the right information, convey the right load, and if there's circuits that are missing off of a panel, or if the voltage is out of range, that could have real downstream complications if that's on our documentation. If that goes out the door on our panel schedules and it gets into the contractor's hands, there's going to be RFIs, and there's a real tangible and financial benefit to making sure that these are addressed and before things go out.
But I think that's a good segue to the next one, data integrity and procurement errors. Can you talk about these ones?
Sure. Identical instances in the same place happens quite often. I would say I don't recall the exact number of what it popped up on our list, but these are things that really impact those schedules. So if you're doing itemized schedules and counts, if you want to take advantage of doing pipe schedules where you have the total length of a certain diameter of pipe at a certain material, that's something that you're going to have to make sure there's no extra sticks laying around on the floor or under the building, perhaps, right? So having those duplicate instances or extra instances or even ones in the same place, sometimes a user places a fixture and it doesn't show up because they use the wrong work set. And then they place it again and again. They go, yes, that's right. I want the wrong work set. That's what Mike told me to do. And you put it in and then you're like, all right, it's there. And they move on and they leave a pile of air terminals underneath that for a little surprise later.
Kenny's blaming you, Mike. Let's move on to number 4 here, model health and graphics, how these impact your daily performance.
Yeah, so just like what Jess highlighted earlier in his, when it comes to elements slightly off axis, that can happen in MEP too, specifically with like pipe risers. And so if you're doing a vent system, sometimes that pipe goes straight up and it's great right at the beginning, but as things shift around, if you have a user that instead of doing like the move command, or they use the nudging with arrows as an example, that could actually move the endpoint on the bottom of that vertical pipe and create this slight off axis. And basically what that does is makes Revit process and calculate even more, that every single time those instances exist, it is recalculating that off axis. Another one I learned, which was pretty interesting, was the IES file as well of a light fixture. If it is moved, so you define a light fixture's IES file, it's a type parameter inside light fixtures. If that original file location is moved and it can't find it, it is constantly checking for that all the time in the background. So I didn't know that until I came to this exercise. So that was a really interesting one. I would say that kind of surprised me.
That's a really interesting insight. I wasn't aware of that one either. And coming back to the number of light fixtures in a given project, it kind of demonstrates how quickly these little things compound. All right, let's switch over to architecture. So, all right, I'm going to ask the same question to Jess and Rowan. Is what, looking at the top 5 or 6 of these architecture warnings, can you describe the impact that these have on model performance, system performance, and coordination and whatnot? And as you can see there, Kenny started off with identical instances, but maybe explain how that impacts architecture.
Okay, let me start with identical instances. So it's pretty straightforward. If you duplicate families, elements, geometries in the model, it can easily overbloat your file size. So if you have a very large Revit model, it probably means that you will have a very inefficient model. So aside from that, you will also have issues with the data, because when you are tagging families in a documentation and you tag a duplicate, and sooner or later you will find out that this is a duplicate and you need to purge all of your model with duplicates, and you accidentally deleted the elements that you tagged, then you have a problem. So another impactful Revit warnings in relation to architecture would be the geometry related warnings. So the keyword here is trust. Like, can I trust the model if the room boundary is not set? So how can I trust the data of these rooms in relation to the areas and everything that reads about these elements? So can I trust a Revit model wherein the wall is not connecting to the floor if I'm going to issue my elevation and whatnot? So it's really impactful, not only to the overall performance. It is because Revit always answer the question of how, what, and when it is loading up and syncing. So if you have, let's say, for example, thousands of Revit warnings, when you sync a model, it will still calculate and try to read all of these warnings, especially in the geometries, trying to consolidate the relationship between the elements. And because of this generated warnings, it will put time and constraint on your loading and syncing times.
I think that's a really common theme, and Kenny had mentioned this with the IES files, is just how Revit just wants to constantly process these over and over and over again. So I think when we get into addressing warnings, we're going to get into how quantity has an impact to your overall performance as well. So if you don't mind, I know Rowan was anxious to talk about the risky business architecture warnings.
Yeah. So this slide isn't illustrating or highlighting just volume of these warnings, but the concentration of risk within these very specific sets of warnings, right? These directly degrade the BIM data integrity, right? These aren't merely performance related issues anymore. They are fundamentally compromising the, how the model calculates, and ultimately, how it can be trusted or not trusted, right? As just said earlier, downstream. So those first two warnings are geometry driven. Identical instances, means that there are two things, two items where there should only be one. So you can therefore not trust element counts and schedules, period. Stair elevation issues tell you that you don't have enough risers, or you have too many risers, or your stair has runs that are too long or not long enough. So that's a big deal, right? Code violations, perhaps, right there. And the other ones, improperly enclosed and overlapping rooms or areas, all point to these analytical calculations, right? Where rooms aren't properly bound or they're duplicated within the same region. Then any data derived from them, area, volume, occupancy, or any other analyses, just becomes unreliable. So these aren't just modeled elements, but analytical constructs, right? And so and looking at you're not dealing with modeling issues at this point, right? You're compromising data sets that drive your code compliance. A lot of firms utilize these for code compliance calculations, life safety calculations, BOMA measurements, energy modeling, cost estimating, program validations, facility operations, perhaps later on, right? So, and also looking at the counts of these, 2.6 million, right? Hints or indicates there's like these workflow issues, perhaps systemic workflow issues instead of just isolated mistakes, right? So from a practice perspective, this is where that more disciplined or data-centric modeling approach it becomes more important, right? So these aren't just your regular model cleanup tasks, right? But in the context of digital maturity, like you said earlier, Chris, we have to treat these warnings. We should treat these warnings as indicators of data risk, right? So that's why they all have this risk of 10.
Right. One of the things I think you really hit on is the information within the models, and I know sometimes in some circles BIM is a dirty word, but for a lot of us, we've been using Revit for 15, maybe even close to 20 years now, and we've come accustomed to using the data within these models for these everyday processes, like you were saying, whether it's life safety calculations or BOMA, that really have legal impact on top of all this as well. And it really starts, and what you really hit at is it starts with the understanding of what that room is and what its purpose is and what's the information and how that drives the overall project. I like to kind of move on here, just so we're keeping up with the schedule here and make sure we have enough time to get through everything. Is we're getting into performance impact. So one of the things I quickly did is looked at all these models, how many warnings, and how many of them were high, medium, low, and try to say, hey, can we just make a score of all this and see that distribution of a simple A, B, C, D, F score? And as you can see, most actually looked pretty well, which was quite surprising. But we still had that level of troublemakers. An interesting fact here is Kenny and I just kind of blindly threw out our scoring system, and it turned out we were exactly on par with one another, thinking how is this impact, how is the performance impact of each of these warnings on a model. So just a little interesting finding here when it comes to how can you track overall model performance impact by warnings. So resolving warnings. So it's one thing to say, hey, these are all the issues with all these warnings, but how do you actually clear this up? So we're going to do this again, start with MEP, and then we'll get into architecture here. But here, I just for reference, here's the list that Kenny has used for many years addressing MEP warnings. So with this experience and knowledge, this is what Kenny has learned to be proactive with these warnings. So Kenny, if you wouldn't mind just kind of quickly walking us through the next few slides on this list that you've generated. And I think for the audience is, I understand this is probably a lot of information, a lot to take in, but this is something you can reference later and kind of get into the details of this information at your own leisure.
Sure. Yeah. So pursuit of warning free. You know, you guys ever heard of clash free model? I don't think we've ever heard of a warning free model either. And trying to get all the warnings down to 0 is next to them. It will be an impossible task, but getting as low as possible is always our goal and our mission. And again, deciding on what your intent is of your model, understanding what the capability and delivery of your team, your model as a whole, helps solve and kind of direct you into what is important and what is not important. So if you have models that you don't do calculations out of, or if you don't use them for analysis purposes, some of these may not be necessary to go and address right away. I know for me, if in my models, I like to have everything connected. I like to have it be the single source of truth and export that information out to calculation platforms and different software. So for me, and what I've identified here in my time is those critical high priorities, like fix these right away, is those system cannot calculate, the system is broken, disconnections and invalid systems. Those are pretty great. And as you can see with these other ones too, a lot of these have a theme, right, of having systems related connections, duplicates, miscounts. But some of the other ones are like the medium and the low ones. It's just very minor cleanliness. Do these when you can find time type of stuff. Don't drop everything and fix it. You can go to the next slide. And a lot of the root causes for majority of these warnings, it's probably, the picture's probably been painted for everybody as we've been talking about it, is this, what are those connections? It's all about connectivity and micro gaps, right? Those micro gaps are like 1,000 little gremlins in our models. And sometimes you're just drawing to draw and you're not doing the entire system yet, but you just want to add a couple of pieces of duct here and there, or you copy an entire layout up to the next floor. And maybe you don't go back and connect it. You're like, it lines up with the duct loop. That's great. Let's keep moving. It looks good on paper, right? We just need to deliver a PDF. Go. Okay, that's totally acceptable if that's the intent, of course. So again, your intent and your purpose will drive some of these decisions you have to make. But ultimately, what supports those systems, what supports the output, families, content on item number 3, are we using the right families? Are we using families that are set up for that type of delivery as well? We could make really simplified families that go clean and fast, and they get the documentation really, the users love them. But then when you try to elevate that content to something more than that, you kind of run into some barriers. So have a strategic planning with your content. What do you want it to be this year, next year, and the year after? Helps kind of resolve some of these future errors from coming out. But I think the one thing that we try to educate our users on is kind of what's your daily workflow? What are you doing your day-to-day to help keep these down? Because the BIM manager can't do everything. The users can help to some degree. So trying to set up a mindset or a strategy or even like a daily workflow, the first 5 minutes you get, check your warnings quickly. If you see anything system related, go ahead and give it a quick look, take care of 3 or 4, and get back to what you're doing. You know, whatever we can do to encourage them to have visibility, because to them, it's a pop-up, it's gone, my model still works, keep going. So there's education there. And lastly, on this slide, I'll state the diagnostic mindset, right? If you see X, check Y. You know, if you see something, say something. If this thing pops up and says flow issues, and you know, like, oh gosh, you know, I use my color fill legend that shows duct flow or pressure, that probably is going to impact that. Maybe I go check it out. So your users also have to be of that mindset of like, what is the intent of our design model? What is the intent of our what is also expected of our deliverable? Because that might impact the client's goals as well.
I like the simplicity of that little chart. If you see, check this. So if you wouldn't mind, Kenny, in preparation, you kind of talked about what does this really kind of mean at a high level, and if you wouldn't mind expanding upon that.
Sure. So managing these for the engineering side of things, it's measured, we have to classify these things by impact and the goals and intents of our projects, like I mentioned before. And I think that changes as we go through our design phases. What's the intent of concept and design development? Do I need to connect everything and make sure my warnings are near zero through that exercise? Probably not. At that stage, you're really doing main equipment, you're doing the main distribution, or the main duct loop as an example. You can have air terminals, you don't have to go through fully connecting them. Those critical fix items might show up and say there's no connection or there's disconnections, and go resolve this now. So I think as the intent or at least I'll say the focus grows as we go through our design, in the construction documentation, yeah, you probably want to have very accurate models. You probably want to have it be more connected, because when things move from a coordination standpoint, I move a duct, my air terminals and flex duct kind of flex, or my flex duct flexes with it, or I move air terminals, everything stays connected together. If it's not connected, then things get broken. Things don't move with each other, and you have, I guess, the expected behavior that you'd want is not there, and it's not consistent across staff.
Right. Out of sake of time, I know we're kind of on the hour, but we have more good stuff to go through here. So we're going to transition here to resolving warnings. So this is the process Jess has adopted. So Jess, if you wouldn't mind just kind of walking us through your approach to resolving warnings, and ultimately, while I prefaced this about architecture warnings, ultimately this is for all warnings. So Jess, why don't you take it away?
Okay. So when we talk about solving Revit warnings, our team usually do this in two ways. So first is reactive, where we wait until warnings accumulate, then we go back and fix them. So the other one is proactive, where we build workflows, build standards and habits that reduce warning creation in the first place. So reactive approach is sometimes unavoidable. In some cases where you inherit models, when you work with legacy projects, when you're working with models transitioning from one stage to another, or when you receive files from external stakeholders. So in these kinds of situations, the model already carries warnings that is a priority to assess and clean up is a requirement. So again, we have examples that I will show later on, but at the end of the day, reactive management is still a catch-up work. So that's why we don't prefer to do it this way, because it will require time. It usually happens under pressure. And it means the team will be spending effort to correcting these issues that in the first place should not be introduced in the file. So another approach would be our preferred one, which is the proactive approach. So it relies in three things. Number one is user awareness. Number two is monitoring tools. And number three would be a sound, non-negotiable modeling standards across the board. So I really like Kenny's presentation about the diagnostic mindset, where you see, if you see X, then check Y. So if your team have that kind of mindset, then the model health stops being a side task. It becomes part of the delivery. So long-term warning reduction is not just a technical exercise. So there should be a long-term approach to this one. And I've cited four examples, like number one, education. So I really like one of the comments here, which points out that training is one of the critical part of resolving or putting in a long-term approach in terms of warnings. Of course, deployment of proactive management tools such as Guardian, which I will also briefly discuss later on. And probably this is an idea from Kenny as well. So organizing a company-wide activities that is stimulating in nature, make it more fun, so that the team will not feel forced to resolve this thing For example, organizing games wherein you can introduce or reward teams that has the least amount of warnings in their projects. But again, it is subjective. It depends on the condition of the project. But at least put in some effort to instill to the mind of the team that Revit warnings is not just a background work, but it is critical to the overall success of the project.
I love the idea of having a competition, so people they win not just on the day to day and with their models, but also kind of have fun and have a little prize along the way. So if you wouldn't mind just kind of quickly going over sort of your traditional approach here with your
So the organic Revit approach would be to work Revit warnings using the usual Revit warning dialog box. Not very intuitive, but still helpful. But you can also extract this information in an HTML file where you can easily copy the IDs, put it in Revit, and Revit will automatically scan through the element that has that element ID. So another approach would be for next slide, please. So in an advent of AI assisted platforms, what we did is we developed an in-house tool where we easily consolidated all of the priority warnings that should be addressed as soon as possible. So this tool technically removes some of the extra steps during the initial process that I've shown earlier, and you can easily go to the elements that are causing the Revit warnings just by clicking the items, and the staff or anyone in the office can resolve this warning as soon as possible.
Nice. So why don't you talk about the proactive approach?
Okay, so for proactive approach, one of the measures that we did is to incorporate a platform such as Guardian. So I know Chris will discuss this in detail later on, but just to give you an idea, we use this to at least provide some level of restrictions to our staff. If we consider a warning as a high priority warning, we put a prevent restrictions to it, wherein the staff will first ask question before they can proceed with the action. That's why so the B manager or anyone considered senior can advise them what will be the repercussions, what will be the possible problem if we're going to proceed with the action. So that is one of the most important thing that we are trying to incorporate in the office, which is education. We're not just giving everyone a free pass to do something that they wanted in a model. At least provide them education before they can proceed. So when they become the project manager of their own, they can easily transfer the knowledge.
Yeah, that's really insightful there. And to take it that one step further, as Jess had mentioned, is here with Guardian, you can see you can provide that traditional monitor, guide, and prevent to every warning. And so here, in this case, duplicate instances, I think we've demonstrated how impactful this particular warning is to your project. And so here's an opportunity to provide education. And you can even take it one step further, is you can actually prevent users from executing that warning altogether, or password protected. So as Jess had highlighted down here, import model too large, right? He had that set to prevent. There are just some things that is not good for the model, and educating the user in real time becomes really important. So a couple of things here is warning maintenance. So we kind of recommend is anything that's at a high priority, you address immediately, and medium priority, weekly, and low priority as the numbers increase. And every once in a while, you're going to have some that really don't have much of a priority at, and you kind of address them as necessary. And lastly is, as we showed earlier, is we have the high priority, but we also have the high risk. And so in the back of your mind, while we don't currently track risk, is you need to know that some of these do have that risk, and they also need to be prioritized immediately or potentially weekly. And I think Kenny had shown that really well. So some key takeaways here is warnings don't just slow your model, they slow every click down. So this is something that warnings build over time without ownership or people owning that responsibility. And I think Jess really spoke to that eloquently, is that's everyone's responsibility to own the warnings in the model, because ultimately if no one does, the warning count snowballs. Also, it's really important for all the users to really read the warnings in context, because not all warnings are created equal. And same time is not all equal warnings are equal depending on the context as well. So hopefully you kind of gather that along the way. As we mentioned that previously, triage the risky warnings first, right? How to prioritize your time. Those risky ones are the ones that you should be doing as soon as they happen. And then I think someone mentioned this in the chat, set a time on a weekly basis to go through as a team, make it fun, as Jess had mentioned, incentivize teams to actually go through and clean up their warnings. And this kind of gets into warnings impact performance, not just only by priority, but also count as a combination of those. And as everyone had from the MEP side really spoke about, is calculation and circuit warnings can invalidate deliverables if left unresolved, right? If you're using Revit to do those MEP calculations, warnings are that first indicator that your results are not going to be correct. And then, and I think John had mentioned this in preparation, is model the system versus the element. And so this is kind of flips the way engineers traditionally think, but you got to think like Revit a little bit sometimes. And I think Kenny put this well here, is digital maturity. This is something that if you really want the full capabilities that Revit offers, and we see the full potential Revit offers, and I think everyone here, part of the panel, has demonstrated that there's a lot of upside, but you also have to understand the warning signs along the way that comes along. So I would, with that being said, I know we're well over time. I want to leave it open to Q&A. But before we do that, I just want to thank for everyone who is still here. Thank you for attending, and especially thank you to the panel for all the hard work getting to today, presenting this great information on Revit warnings. So I'm gonna ask one of my teammates if there are any questions out there, and if anyone has any questions, please raise your hand. All right, great. I'm going to take the silence as there are no questions. So again, I want to thank everyone for their time today. Oh, there's a question there.
It looks like there is one.
Yeah.
Okay. If you wouldn't mind reading it. Unfortunately, I'm blind to the chat from my end, so.
I do see a hand raised.
I believe you should be able to unmute yourself.
Yeah, hey, this is Steve Wolford. I really appreciate the insights, and in particular, the distinction between warnings that are degrading performance with every click and warnings that are quality control if you're getting garbage data out. We are most interested in resolving the biggest warnings that are degrading performance. What's the best way to get a list of those?
I'm going to ask the panel to answer that, if you don't mind.
Guardian's
is
a
the
great way. It gives you a pretty good list of everything. They've also gone through and assigned it with some preset high, medium, lows.
Yeah, my
For the
issue
most
is I
part, they're
can't.
pretty good.
My issue is I'm unclear as to whether they're saying high because it's performance or high because it's risky or a combination thereof. As I say, I really need to focus on performance issues.
There is a top 10 list out there on the interwebs of bad modeling practices that can lead to performance issues. Work sets being used as layers is one of them. I'll throw that at the and imported CAD another. But that list is out there, man. I'll look that up.
And to speak more specifically on the high, medium, and low, is really these, when we talk about the impact, say the performance impact, or sort of the engineering or the BIM impact of that. I think that's a better way of putting it. Is it really the information side of it? That's how the high, medium, and lows are really applied. So, duplicate instances ultimately is both a performance impact and also a data impact, because your data is now skewed. Your takeoffs are now skewed. But great questions. Hopefully that answers your question.
I
Go
can
ahead,
answer
Kenny.
that as well real quick. So if you think about warnings and just think of it in this sense, things that have to do with relationships between components, between elements, those are relationships that Revit is keeping track of and trying to maintain as much as possible. So if relationships are broken, whether it be a data relationship or a hosting relationship, those are usually performance impacting. Geometry, anything that has geometry to it. So those duplicate elements, those duplicate items, if you have a floor plan that has a bunch of light fixtures on it and somebody copy pasted those light fixtures on top of the existing one, you are now rendering two sets of light fixtures, right, across that entire view. So that's why those ones are probably the most impactful when it comes to performance in your day-to-day for somebody. The duplicate items one can be big if it's left, uncontrolled.
Thanks for that additional context. Steve, did that answer your question?
Yeah, I think it helps me think about them and realize what is really hurting the performance. I think, things that architecturally we don't do a lot of analytical stuff in Revit beyond life safety plans. We're not in fixture counts or things of that nature. So I'm less concerned with the garbage in, garbage out type of warning, but understanding that things like duplicates are also slowing down, re-render time and stuff is something I hadn't thought about before.
Nice. Thank you, Steve. Any other questions there?
I saw
All
a
right.
question from Sam. Sorry.
Okay, go ahead. Go ahead, Jess.
So there's a question: how do you encourage user engagement, review, and awareness of warnings, trends, and impacts? So what we did is we did it in two ways. One is more administrative, and one is very ad hoc. So in terms of administrative, we created checklists, reports, which we disseminate to the team, internal team, and the team of our clients. So it outlines all of the issues in the project, and it also includes Revit warnings and how to deal with it. Another thing is we have a knowledge base for everyone, which will be shared to the newly onboarded staff. So before they join our team, we ensure that this information, including Revit warnings resolution and how to deal with them, will be incorporated and will be taught to them so that they will, when they are in the project, they will ask questions about it.
I love that, Jess. And really what you're speaking about here is it really comes back to a thesis of this whole thing is warnings impact the performance of the project, right? We've talked about the model quite a bit, but the project is something that is more holistic, um, that is external to the model, and that if you're delivering a good product, these little things these warnings will be a hindrance to delivering that, right? And so getting everyone on the same page to understand the importance of warnings to the quality of the product that you're putting out, and also making sure at all levels everyone understands the value that this effort of addressing warnings, keeping up top of it, ultimately helps everyone and helps you deliver a better product. I would love to continue answering more questions, but we're a little bit over time, to say the least. But I appreciate everyone who's here, and again, I really appreciate the panel for the effort getting to today and presenting today's webinar on Revit Warnings. So again, thank you all.